Hello guys, today we're going to be going over solutions and the solubility curve and how you can read a solubility graph. And you're going to be going over some of those solutions that we have already done. So you're going to distinguish among different types of solutions. So you're going to be able to identify whether it's saturated, unsaturated, or supersaturated. And I'm going to show you how to do that right now. Okay, so you're still going to be using the terms that we've already spoken about. So, for example, anytime you have a solute, that is what's being dissolved. Whenever you have a solvent, this is what's doing the dissolving. Okay, so once that solid is dissolved in that solvent, you have a solution. Now, we already did molarity, and that allows you to do how many grams you can put in a particular amount of water, and that's part of your graph that you're going to do today. You can also dissolve a liquid into liquid or a gas into liquid. Okay. Now, an unsaturated solution means that you can get some, let's say, sugar into water, and let's say you do a teaspoon. Okay, a teaspoon is going to be about 4 grams. And if you have a beaker, a large beaker of water, you're going to have plenty of space to dissolve more sugar. That's an unsaturated solution. Okay, so an example of that would be this first picture over here. This right here is an unsaturated solution. So think of this being tea, because this is so diluted, you can actually add more to it. It's very unconcentrated, or it's a low concentration. That is unsaturated. I can actually put more of the tea in there and it will still dissolve. Now, a saturated solution means that the maximum amount of what can be dissolved in that amount of liquid, and it cannot dissolve anymore. If I add more, it starts to sink to the bottom. Think of a glass of tea again at a restaurant, and you can't dissolve anymore. Where does that sugar go? The sugar goes down to the bottom. So once you can actually dissolve as much as you can, that is a saturated solution. So this middle one is kind of an example of that. Okay, now a supersaturated solution means you have to do something to it. You have to change the temperature or stirring or something, or the pressure, to where it will dissolve a lot more of your solute. That's a supersaturated solution. So if in this beaker, let's just give an example, you could only dissolve 30 grams in that amount of water, but you were able to dissolve 50 or 55 grams, that is a supersaturated solution because it went past the amount it was originally capable of dissolving. Okay, so right here you have the same amount of liquid in a beaker, but here obviously whatever your solute was, it dissolved completely and you can't see anything in there. So when there are no crystals formed at all and it's completely dissolved, that is unsaturated. Now, when you have a few crystals, it does dissolve, and you've dissolved as much as that amount of liquid is capable of dissolving. This is a saturated solution. Saturated solution. Okay, now when you have dissolved more than what it's capable of dissolving, and you've done something to it so it can absorb that solute, that is a super saturated solution. Okay, and so this is how you can make like rock candy and stuff like that. All these crystals will form and you can literally pull them out. Okay, so looking at this glass of water, something's dissolved in there, but now you've got a lot of sugar sitting at the bottom. So what type of solution is this? Is it unsaturated? saturated, or supersaturated. Little hint, look at the bottom part of that glass. If you said saturated solution, you are correct. Because the water has dissolved as much as it can, all of this is here in the water molecules. It is now part of a solution. However, that amount of water can no longer accept any more of that solute to dissolve. Therefore, the rest of it goes to the bottom. This is a supersaturated solution. Okay, now when you look at solubility in a graph, your curve is going to depend on whether you have a solid or a gas. The higher the temperature, the more solid can be dissolved. So I'm going to, in a minute, give you a certain amount of temperature and give you a certain amount of grams of, let's say, water. And wherever you plot, if that plot is right on the line of that particular chemical, then it is a saturated solution. If that dot or that plot is under that chemical line, then it's an unsaturated solution. However, if I give you a temperature and amount of grams and you have your plot above that chemical line, it's going to be a supersaturated solution. So one more time, if it's on the line, it's a saturated solution. If it's below that chemical line that you're looking at, it's going to be unsaturated. If it's above that chemical line, it's going to be supersaturated. Okay, so now let's do an example. In your problem, they're giving you 90 degrees Celsius, so you're going to look up that on your temperature line, 90 degrees, and they're going to give you a total amount of grams of a particular chemical, because you might have other chemicals crossing in this same solubility curve. So in this 100-gram sample, 40 grams lands right here, and your dot, your plot, is right on the line. So is this saturated, supersaturated, or unsaturated? Because it's on the line, the chemical line, it is a saturated solution. Okay? Okay, let's go ahead and do another example. If I give you a problem where I ask for 40 degrees Celsius and let's say 50 grams of your solute, and let's pick something like, let's do ammonium chloride, NH4Cl. So now you see all of these lines, they're different chemicals. And that NaCl, that chemical line, is right here. So 50 is going to go all the way over here, and we're going to go to 40. So 40 is right here. So if it's above the line like this, that means it's going to be a supersaturated solution. So now let's go ahead and do something like 10 degrees with that same 10 grams with that same 40 degrees Celsius. That 10 grams is right here, and the 40 is right here, so your plot is right here. Because your chemical line of NH4Cl is up here, this is way below the line. That's going to make it an unsaturated solution. Okay, now, I hope we got those examples. If we need a few more of those examples, we can do them on Zoom. Please ask me for help on that, okay? All right, so now, how can I tell if I have solids or if I have gases? And quite a few of these are also going to be in liquid form. Now, if it's going up and it's curving up like this, it's a solid dissolved in a liquid, okay? Now, if you have something gas, now can a gas dissolve in a liquid? Okay, yes, gas can dissolve in liquid. A good example of that is the soda that a lot of us drink every single day. Okay, that's a carbonated drink. So that gas is actually dissolved inside that liquid. this not only changes your freezing point, it changes many other things as well, like melting point, boiling point, freezing point. Because you have different solutes in that liquid, it can change the temperature it freezes. For example, something like sugar will definitely freeze or boil at a different point in a soda than it will in water. Okay? Now, how can I tell it's a gas that's doing the dissolving? A gas will dissolve more if it's at a low temperature. And it's going to have more grams that are being dissolved. So look at this one. You have 90 grams that are being dissolved. At the higher the temperature gets, the less of that solute is being dissolved. So that line is going down, unlike the solids that are going up. Okay? With a solid, the higher the temperature, the more you dissolve. With a liquid, the lower the temperature, the more you can dissolve. Okay, and so it's opposite. Solids and liquids are going to be reversed. Okay, so let's do a couple of examples. You have 55 grams. 55 grams would be about here at 20 degrees Celsius, which is right here. So let's go ahead and go all the way up here, and then here you're going to meet that line. Okay, and we're talking about NH3. So here's your line for NH3. That plot seems to be a little bit above the line. Okay, so what is that? Is that saturated, supersaturated, or unsaturated? Okay, you're going to tell me in a minute. Now let's look at number 2, and let's do that in a different color. And we're going to do 10 grams. And so 10 grams are right here. To 10 degrees Celsius, and 10 degrees is right here. Okay, so 10 and 10. And we're going to use the chemical CeSO4. CeSO4 is right over here. Okay, so that seems to be below the line, that chemical line of the Ce, below. So now, is that supersaturated, saturated, or unsaturated? Okay, we can feel free to pause and discuss that. Okay, so now let's do the third one, which is 145 grams at 80 degrees Celsius. So here's 80, and 145 is about here. So 80, let's go all the way up, and 45, it's about there. It seems to be at about on the line of NaNO3 of that chemical. So is that supersaturated, saturated, or unsaturated? Remember this NH3, it seems to be above the line. The CeSO4, it seems to be below the line. And for the NaNO3, it seems to be exactly on the line. So go ahead and pause and then tell me what it is. Is it saturated, supersaturated, or unsaturated? Okay, so for that first one, it was supersaturated because it was above the line. For that second one, the 10 to 10, it was below the CeSO4, so is unsaturated. And for number 3, it's saturated because it's right on the line. Okay, looking at this graph, which chemicals are gases? Now remember the rules. The cooler the temperature is, the more you're able to dissolve a gas. So for example, when you have a soda and you want for it to stay carbonated, you can put it in the refrigerator so it will remain carbonated for a longer period of time. Okay, if you said NH3 and CeSO4, these are actually curving down. These are gases. Very good. All right, guys, if we have any questions on this, let's go ahead and talk about it in Zoom, and we can do more examples in Zoom. Have a great day.